Let's do two examples, integration using u-substitution, but that also involve some trig expressions. So we need to evaluate the integral. In this case, we have sine to the fifth of x over 3 times cosine of x over 3 dx. So one thing that we know is the derivative of sine is cosine. So we see a derivative hiding inside the problem. So the first thing would be, how do I choose my u value? Often when we're dealing with sine or cosine raised to a power, we might rewrite that. And I could say, well, this is the same as sine of x over 3 to the fifth times cosine of x over 3. Let me write it like this. X over 3 dx. So in this case, now I see I have sine of x over 3 raised to a power. I'm going to choose that. I'm going to say, well, let's let u equal the sine of x over 3. And that means then the derivative of u with respect to x, the derivative of sine is cosine. So that's the cosine of x over 3. But when I'm taking the derivative, in this situation, we need to use the chain rule. And so the derivative of my inside here, the derivative of x over 3, which is the same as 1/3 x, that's going to be times 1/3. So that 1/3 came from using my chain rule to take the derivative. All right, so if I start trying to substitute, I get the integral of u to the fifth. And I need to determine how to deal with this. I need this piece to look exactly like what I've underlined here. I need only cosine of x over 3 dx. So how am I going to do that? Well, I could multiply the dx over. This is the same as du equals 1/3 cosine of x over 3 dx. And then I could multiply by 3 on both sides. 3 du equals cosine of x over 3 dx. So this cosine x over 3 dx is exactly the same as what I have up there. And what is cosine x over 3 times dx equal to? 3 du. So make sure you understand how I created that substitution. At this point, now it's very easy for us to integrate. This is the integral, or 3 of the integral from u to the fifth du, which is u to the sixth over 6 plus c. Of course, that 3 is in front. So plugging my u value back in, remember u is equal to sine of x over 3, I'm going to end up with 3 over 6, that is 1/2 sine of x over 3 raised to the 6th, and you can use those parentheses however you'd like, plus, you might think, well, I need to write 3c, but again, c is an arbitrary constant. I don't need to distribute a number and multiply it by 3. We don't know what it is. A number times a number is still an arbitrary number. So we just write plus c. And that is my indefinite integral. Let's do one more with sine. So here we're going to evaluate another integral, an indefinite integral. It has trig and an algebraic expression in there. We're going to use u-substitution. We have to determine how to choose u. So let's look at our integral. We have the integral of x to the 1/2 times sine of x to the 3/2 plus 1. I could choose x to the 1/2 to be u. I could choose sine of x to the 3/2 plus 1 to equal u. I could choose the argument of my trig expression, x to the 3/2 plus 1 to equal u. I mean, I have other choices. I could just pick this x to the 3/2. So we have lots of choices. We have to decide what's best. And going back to our rules that I mentioned at the beginning of this section, when we have trig, sometimes we will pick that argument. All right, whatever we are taking the trig function, we're applying the trig function to. So in this case, I'm going to say, well, let's let u equal x to the 3/2 plus 1. So what does that mean for my derivative? The derivative of u with respect to x equals 3/2 x, take away 1, you get 1/2, and then the derivative of 1 plus 0, which we don't need to write. So I have 3/2 x to the 1/2. And I see x to the 1/2, so I'm on to something. But I don't have that 3/2. Well, again, we're going to rearrange this. So du equals 3/2 x to the 1/2 dx. And then I've still got that 3/2. So I can say, well, this is 2/3 du x to the 1/2. So I multiplied on both sides of the equation by 2/3. The 3/2 on the right is gone, and I now have a 2/3 on the left. So x to the 1/2 dx, I have that. I have that in my integral. So this is the integral of, I'm just going to rewrite this, sine of x to the 3/2 plus 1. I'm going to move x to the 1/2 to the end because multiplication is commutative. So I can see that right here. It's in there. I have my u value that I can plug in, and my du is going to be equal to this. So what that looks like is this is now the integral of the sine of u. U is my new argument, and x to the 1/2 dx is equal to 2/3 du. All right, so this is equal to 2/3 the integral of sine of u times du, and the integral of sine is negative cosine. So I have negative cosine u plus c. And I just need to distribute that 2/3 or tidy it up and then plug my u value back in. Remember, u is equal to x to the 3/2 power plus 1. So my final answer here is negative 2/3 cosine x to the 3/2 plus 1 plus c. And that represents the value of our indefinite integral, which is an antiderivative. And so I know I mentioned this when we were learning about antiderivatives, but you can always check your answer by taking the derivative, which we should feel very confident with at this point. Okay, so you can check it and take the derivative, and that would give you back exactly what we started with, that integrand. All right, so we've done 2 indefinite integrals using u-substitution.